Hi everyone, it's been a while since I posted, but I finally got a perfect score in a bronze contest, so I'm going to go over the solutions for all three problems, just in three separate videos. In this video, I'll be going over problem 1, majority opinion. So Farmer John has an important task. He has to figure out what type of hay to buy for his cows. He has n cows which he numbers 1 through n, and each cow likes exactly one type of hay. He wants all his cows to like the same type of hay. In order to do so, he can host focus groups. A focus group consists of all cows in a contiguous range, and if there's a type of hay that more than half the cows in the group likes, then after the group finishes, all cows will end up liking that type of hay. If no such type of hay exists, then no cows will change the type of hay that they like. For example, if there are 16 cows, 9 or more of them would need to have the same hay preference for the remaining cows to change their preference. Okay, so Farmer John wants to know which types of hay can become liked by all cows. He can host one focus group at a time, but he can run as many focus groups as he wants. For the input, you'll get an integer t, which is the number of test cases. And then for each test case, you'll be given an integer n, which is the number of cows. And then finally, the preference of hay for each cow. For the output, if it's possible to make all the cows the same type of hay, you have to output all possible types of hay in increasing order, so from least to greatest, otherwise output -1. So let's just run over some test cases and try to find a pattern, and maybe that'll help us solve the problem. So for the first test case, we have n is equal to 5, and then 1, 2, 2, 2, 3. Okay, so n is equal to 5, 1, 2, 2, 2, 3. Okay, well, if we have one focus group and we enclose all the cows, right off the bat, we can see that the most predominant hay preference is going to be type 2, right? Because there's 3 of them. And so the number of cows that like type 2 is 3, and the total number of cows in the group is 5. 3 over 5 is well over 1/2, and so therefore all the cows will switch their preference to 2. Now if you try this on any of the other cows, any of the other hay preferences like 1, you can see that no matter how you group them, nothing will work. You can never get the answer to be 1, 1, 1, 1, 1, 1. That's just impossible. Same for 3. So the only answer will be 2 in this case. And yeah, if you look at the first output, it's 2. Second test case, you have n is equal to 6, 1, 2, 3, 1, 2, 3. So n is equal to 6, 1, 2, 3, 1, 2, 3. Okay, let's try grouping as many ones as we can. So like this. Well, if we do this, then the number of ones is 2, and the total number of cows is 4. That's exactly 50%, or half, which is not enough because we need more than 50%, and we're not there yet. So this type of grouping won't work. It won't help us at all. Now let's try grouping the 2's together. Same thing. If we group all the 2's together, then we have the number of 2's to be 2, and the total number of cows in the group is 4, right? 1, 2, 3, 4. This also won't work because this is also 50% and not enough. Same thing if we group the 3's together. Okay, for the next test case we're going to look at, we have 1, 1, 1, 2, 2, 2. 1, 1, 1, 2, 2, 2. Okay, over here, we can try making everything ones. So let's try grouping these 3 together. Now this will become 1, 1, 1, and then this 2 will become a 1 because the number of ones in this group is 2, and the total number of cows in this group is 3. 2 over 3, well over 50%, therefore everything in the group will turn into 1. Like that. The rest is 2. If we do the same thing, you can notice that this is the exact same thing. Now this will turn into 1, 1, 1, 1, 1, 1, 2. Finally, we can do it once more, and then we'll get everything to be 1, like that. And you can kind of see that this is also identical for the 2's. So we can group everything like this. Then we'll get 1, 1, 2, because there are 2 2's, like that. And then we can do it again, and then again, and then we'll finally get everything as 2's. So the answer will be 1, 2. Right here. So, one thing to notice is that we must have at least 2 of the same type of hay in order to change the preference of a cow. For example, if we have n is equal to 3, and we have 1, 1, 2, this is perfect to change the preference of this cow. Because if we group them all into one group, the 1's hold the majority, and therefore the rest of the cows, hence this one, will change the preference. So it'll become 1, 1, 1. No other case is going to be as efficient as having only 3 cows. For example, if we have one more 1, this won't do anything. Grouping it together, sure, it'll also become 1, 1, 1, 1, but this, oops, that didn't delete it. This is a lot more efficient. All we need is just 2 cows of the same type, and then any other cow that we want. And then this cow will change its preference, no matter what. Okay, so now we know that as long as 2 cow preferences or 2 hay preferences are next to each other and they're the exact same, that's all we need in order to change the preference of every cow available. Now let's take it one step further. If we have, let's say, 7 cows total, and then we have 2, 2, 2, 1, 1, 2, 2, so n is equal to 7, 1, 2, 3, 4, 5, 6, 7, yeah. We can use these 2 cows and put a focus group here, change it to 2, 2, 1, 1, 1, 2, 2. Next we can host another focus group, because keep in mind we can do this an infinite number of times. So we can go like this, and then so on until all the cows have 1's. Alright, well there's a special case, and we'll find out in the next test case, where we have n is equal to 3 and we have 3, 2, 3. So if n is equal to 3, and we have 3, 2, 3. The 3's aren't next to each other, but if we use one focus group to kind of incorporate all 3 hay types, this will also work, and we'll get 3, 3, 3. So we can see that as long as they are next to each other or one apart, these are always sufficient in getting us 1, 1, 1. So these cases will always give us the same thing, and that's fine. Okay, so now I'm just going to go over the code because I think it'll be easier to understand once you have the code. So this was the code submitted in contest. So first I inputted the number of test cases. I loop over the number of test cases, and then I input the number of cows and also the hay preferences. And then after that, I create a set called answers. And the reason for this, the reason why I use a set, is because oftentimes, as you'll see, we're going to be inserting a lot of duplicate answers. And what sets do is that they don't take into account duplicates. Every element in a set is going to be distinct. And that just makes the number of elements much more easier to manage. Also, sets are sorted, and then that's going to be very helpful later on. Okay, so after we create the set, what I'm going to do is loop over the preferences. Along the way, I'm going to have this long conditional, so I'm going to break it up into 2 parts. The first part is this, and the second part is right here. Either or must be true in order for this code to run. So in the first conditional, what's happening is I check if the index right after the one I'm at right now is within bounds, and the next element is the exact same as the one I'm on. So for example, if we have 1, 1, 1, 2, 2, 2, and then we have the indexes above. So index 0, 1, 2, 3, 4, 5. Everything else can be deleted for now. Not too important. Okay. So the first conditional is essentially checking. I can just copy over. Okay. The first conditional is checking if I plus 1 is less than n, meaning that if I is currently here, so if the iterator is currently here, it checks if the next index is within the range and they're the same elements. So if these two are the same elements, then I can add h sub I into the set. Otherwise, don't add anything. And the reason why I check if the next element is within the range is because if I'm at index 5, I want to check the next index, right? Index 6. However, that's out of bounds, and I don't want to try accessing it at all. So I have to make sure everything is within the bounds. Okay, the same thing goes for this next conditional over here. So over here, we check if I plus 2 is within the bounds. So for example, if I'm over here at index 4, I check 1, 2 over, but that doesn't exist, so we don't even want to touch it. However, if we're over here at index 1, we check 1, 2, index 3, I plus 2 is index 3, and it's within the bounds, so that's fine. Now we check if h sub I, or this element, is equal to h sub I plus 2, or this element. And since it's not, we don't add anything to the set. But if it were, we would. And that just means that that's one of the possible answers. So essentially, all that the answers set is including are possible answers. Next, we create an iterator called ans, or answer, and then we check if the size of the set is empty. If it's empty, that means we haven't even gathered any of the answers and we can output -1, meaning we found nothing. Otherwise, what we do is we have an iterator that starts at the beginning of the set and ends at the end of the set, and then we output the answer. Over here, it's just a little thing that I included for USACO, because what USACO does is it compares your output to the actual output, or the expected output, and if they don't match even because of a space, then your answer is wrong. So what I do to kind of leave out the extra space at the very end is I check if the next answer, the next iteration of answer, does not equal the end, then I can output a space. However, once I reach the end, I don't want to output a space. Alright, so that's about it. If you found this video helpful, please like, share, subscribe, comment, and all that. And yeah, if you have any questions, please feel free to leave a comment asking your question. And yeah, thanks for watching.